Good morning, students. In the last class, we discussed about the equations of motion of a freely falling body. In the last class, we completed equations of motion of a freely falling body. For a freely falling body, u value will be equal to 0, a value will be equal to g. That's why those equations will become v is equal to gt, h is equal to half gt square, v square is equal to 2gh, Sn is equal to g into n minus half. These are the equations of motion of a freely falling body. Let us discuss some points relating to freely falling body. So, in examination point of view, what they will ask relating to freely falling body, we will discuss. First one, ratio of distances. Ratio of distances in 1 second, 2 seconds, 3 seconds, so on, n second is 1:2, 3:5:7 n square. Ratio of distances in 1 second, 2 second, 3 second, n second. That ratio of distances will be 1:3:5:7 n square. What is the meaning of that? Body is freely falling. Here body is there, it is freely falling. Okay? So in the first second, for example, if it traveled 5 meters in 1 second time, let the body came here. If it is 5 meters, wait, total time, this is, so this value will be 1:4:9:16:n square. Okay. In the after 1 second, it came to here. How much distance that is? 5 meters. Okay. Next, how much in 2 seconds? After 2 seconds, it came to here. This distance value will be 4 times of this. Clear? Next, after 3 seconds, finally it came to here. This distance value will be 45 meters. Clear? So, freely falling body we are considering. Freely falling body in the first second of its journey, if it cover a distance x, in 2 seconds it will cover a distance 4x. In the 3 seconds it will cover a distance 9x. Clear? If x is 5, then this value will be equal to 20. This value is equal to 45 meters. Is my point is clear? I considered a freely falling body. In the after 1 second it traveled some distance. After 2 seconds it came to some position. After 3 seconds it covered some distance. The ratio of the total distances covered, if we calculate, that will be in the ratio 1:4:9:16:n. How it is gained for freely falling body. For freely falling body, h is equal to what will happen? Half gt square. So after 1 second, h1 is equal to 1 by 2 g into 1 square, that's value is equal to g by 2. After 2 seconds, h2 is equal to 1 by 2 g into 4 square, 2 square, 4 into g by 2. After 3 seconds, h3, 1 by 2 g into 3 square, 9 into g by 2. So this ratio is 1 is to 4 is to 9 is to 16 is to so on, n square, like that it will be given. Clear? This point is clear. Next. Second one. Okay, body is freely falling like this. This is ground. Body is falling from here. After 1 second, it came to here. After 2 seconds, it came to here. Okay, after 3 seconds, it came to here. After here, body is not enough. Okay. After 4 seconds, it came to here. Let it be. If we compare these distances, after 1 second, after 2 seconds, after 3 seconds, after 4 seconds, like this it is there. Let it be. So, after 1 second it came to here. After 2 seconds it came to here. Its position is here. 3 seconds it came here. 4 seconds it touched that down. So, this distance, this distance, this distance, this distance. This ratio will be 1 is to 4 is to 9 is to 16. Clear? Next, second point. Ratio of distances. Here we can use the term displacement or distance. Both will be correct. Because body is moving in the straight line. Here name of the chapter is motion in the straight line. So body is moving in the straight line. So if we consider that as distance or displacement, both will have the same meaning. Understanding? Yes. Okay. Ratio of distances in first, second, third, nth second is 1 is to 3 is to 5 is to 7 is to 2n minus 1. If this is x, after in the first second it traveled in distance x. This is second. How much distance it will travel? 3x. In the third second, it will travel a distance 5x. In the fourth second, it will travel a distance 7x. My point is clear? In the first second, in the second second, in the third second, in the fourth second, like that in the nth second, ratio of distances covered is 1 is to 3 is to 5 is to 7 is to so on 2n minus 1. How this is came? See, for freely falling body, Sn is equal to G into n minus half. Sn is equal to G into n minus half. Here what will happen? In first second, S1 is equal to G into 1 minus 1 by 2. This value will be G by 2. In second means this one. In the previous problem what we total we calculate. That will be equal to 4x. Here what will happen? S2 is equal to G into 2 minus 1 by 2. This value will be 3G by 2. In third second, S3 is equal to G into 3 minus 1 by 2. This value will be 5G by 2. Like this, if we calculate, that will be 1:3:5:, so on. So in nth second, Sn is equal to G into n minus 1 by 2. So 2n minus 1 into G by 2. G by 2 will cancel. So finally we will get this ratio is 1:3:5:, so on, 2n minus 1. This is the ratio. Clear? Direct theoretical questions will be there on this. Next. See the next point. What they will ask relating to freely falling body, we are discussing now. Okay, next, third one. What is that formula? How that is gained? Both we are discussing now. Next, we have to remember at least that formula, how that is gained. S1 is 2, S2 is 2, S3 is 2, so on, is equal to 1:3:5:, so on, 2n minus 1. Distance ratio of distances in 1 second, 2 second, 3 second, n second, that will be 1:4:9:2, so on, n square. Next, a freely falling body. A freely falling body passes through 2 points. A freely falling body passes through 2 points A and B in time intervals of T1 and T2, in the time intervals of T1 and T2 from the start. Then distance between A and B is, distance between A and B is 1/2 G into T2 square minus T1 square. Freely falling body passes through 2 points A and B in the time intervals T1 and T2 from the start. Then distance between A and B is equal to 1/2 G into T2 square minus T1 square. What is the meaning of that? See, body is freely falling like this. Body is freely falling from this point. To come to the point A, it took a time T1. From here to come to here, it took a time T1. Here point B is there. From the starting to come to the point B, it took a time T2. This is the starting point, let it be O. So to come from O to A, how much time that is? T1. To come from O to B, how much time it is taking? T2. Then distance between A and B is how much? That value will be 1/2 G into T2 square minus T1 square. Simple only this is. So OA is equal to how much freely falling body? Half G T1 square. From h is equal to half gt square. From that formula, OA is equal to half gt1 square. OB is equal to half g t2 square. That is OB. Then AB is equal to what will happen? OB minus OA. OB minus OA means we will get it as 1 by 2 g into t2 square minus t1 square. If that is clear? So in this way, we can get distance between A and B will be equal to 1 by 2 g t2 square minus t1 square. Actually, these formulas will be useful at a particular instant of problems, particular this type of problem they ask. Directly you can apply this formula so that easily you will get the answer. Clear? Next point number 4. A freely falling body. A freely falling body passes through two points. A freely falling body passes through 2 points. 2 points A and B. At distances H1 and H2 from starting time to go from A to B. Time to go from A to B is root 2 by g into root h2 minus root h2. Time here, times, what is the time difference there of simple possibility. Same, in that same case, here owner, here E. Let this distance is h1 to come to that is t1. Let this distance is h2 to come from O to B, body to the time t2. Then what is the time to come from A to B? So this total time is t2. From here to here t1. Time difference is equal to time to come from A to B will be t2 minus t1. How this is came see h1 is equal to 1 by 2 g t1 square. From this t1 is equal to 2 h1 by h2 1 by 2 g t2 square. Then T2 is equal to 2H2 by H. Then difference if we calculate time to come from time to go from A to B is equal to T2 minus T1 root of 2H2 by G minus 2h1 by g, root 2 by g you take common into root h2 minus root h1. This we can get. In this root 2 by g we can take common. Remaining what will be there? Root h2 minus root h1 will be there. Is clear what I am saying? So in this way, problems will be there on the freely falling body. Up to now what we discussed just present. So freely falling body means a body dropped in the air. That will be called as the freely falling body. For freely falling body, U value will be equal to 0. A value will be equal to G. Next. Freely falling body, how the problems will be there, we are here discussing. The ratio of distances traveled by the freely falling body in 1 second, 2 seconds, 3 seconds, n seconds are in the ratio 1:4:9:16:, so on and so on. Ratio of distances traveled in the first second, second, third second, so on, n second is 1:3:5, so on, 2n minus 1. Next, after finishing of that, body is freely falling up to come to the point A. From the starting it took A time t1, to come to the point B it took time t2 from the starting. Then distance between A and B will be h is equal to 1/2g t2 square minus t1 square. Then time to come from A to B will be √2/g into √h2 minus √h1. Next, one more model will be there. Let us see what is that. Next, fifth one, what they will ask, see. Problem will be like this. A stone is dropped into a well. A stone is dropped into a well of depth h and the splash of sound is heard after t seconds. A splash of then t is equal to √2h/g h/e sound. Whenever you observe this line, splash of sound, then in that cases you have to use the formula t is equal to √2h/g plus h/d sound. This formula you have to use. What is that person saying? Here one well is there. This is ground. Here one well is there. Well is containing water. From the surface, means from the ground, we dropped a stone into the well. This is stone. We dropped a stone into the well. What is the depth of the well? H. Okay, from the top of the well, we dropped a stone, and the splash of sound is heard after t seconds. Splash of sound means that stone touches the water, then one type of sound you can observe like that. But then when this stone touches this water, it will produce some sound. That sound you listen after t seconds of dropping. In that cases, you have to use the formula √2h/g plus h/d sound. Here total time will be at t means what? You dropped the you listen. Here two times you have to consider. T1 will be the time taken by the stone to reach the water surface. This stone came from here to here. How much time it is taking? T1 time. Then freely falling body, that stone, then h is equal to, here what will happen? Half g T1 square, then T1 is equal to root 2h by g. T1 will be the time taken by the stone to reach the water surface. When it touches the water, it is producing the sound. That sound will travel in the air. That sound will travel in the air in this manner and reaching to the surface. So then velocity is equal to distance by time. If that sound is traveling in the air, so what we can write in that case? V sound is equal to distance by time. T2 is equal to h by V sound. So total time is equal to T1 plus T2. So this value is equal to root 2h by g plus h by V sound. Okay. T is equal to root 2h by g plus h by V sound. This formula we have to consider in this case. When you have to apply this formula, remember what is the time taken by the stone to reach the water surface means just this only. But they will mention in the problem the splash of sound is heard after t seconds. Find the depth of the well or find the velocity of sound in air. Like that mean they will ask this h there and this ask V sound. You have to use this formula in that case. Root 2h by g plus h by V sound. Next, sixth one. What is that? See? Sixth. A stone is dropped in the air. It is dropped in the air after t1 seconds. It is reaching to the ground. Stone is reaching to the ground after t seconds. Okay. But in its journey, after t2 seconds, we stop that stone. Again we release the stone. How much time it will take to reach the ground? If my question is clear, a stone is dropped in the air. This is the stone. A stone is dropped in the air. It took 10 seconds to reach the ground, for example. It took 10 seconds to reach the ground. But after 6 seconds, what we did, we stopped the stone. This is the stone. We stopped here. Again I release by stopping. Again I release from here. After t2 seconds, it is stopped, and again from there it is released. Still, how much time it is taking to reach the ground? Try to answer the question. From here, one stone is dropped. How much time it is taking? 10 seconds to reach the ground. How much time it is taking to reach the ground? 10 seconds. After 6 seconds, it takes 10 seconds to reach. But after 6 seconds, I stopped this stone. I stopped this stone after 6 seconds. Means time to come from here to here is 6 seconds. Time to come from starting to ground is 10 seconds. Here I stop and again I release. How much time it will take to come to the ground? It will be not 4 seconds. This is 10, this is 6. So this will not be 4. How to calculate the time? Let us see. So how the person will be there? A body dropped in air. A body dropped in air took T1 second to reach ground. But after T2 seconds, it is stopped and again released. From the same point and again released from the same point. Then time taken by the body to reach ground is T3 is equal to T1 square minus T2 square. T3 is equal to T1 square minus T2 square. This formula we have to use here. Why is it? Let it, this is H. Let this will be H1 and let it be H1, let it be H2, let it be H3. H1 is equal to what we can write? H2 plus H3 obviously. Then H1 value will be how much? 1 by 2 G T1 square. H2 value 1 by 2 G T2 square. H3 also 1 by 2 G T3 square. Half G both sides will cancel. T1 square is equal to T2 square plus T3 square. From that T3 is equal to what will happen from this? You see T3 square is equal to T1 square minus T2 square. Therefore T3 is equal to square root of T1 square minus T2 square. We will use this formula in that case. Totally 6 type of problems will come in this freely falling body. We discussed all the models. Next we will come to vertically projected body. When same type of problems if you do on the same concept, then you can be able to understand how to apply that formula. Understanding? Next, vertically projected body. Up to now, 6 are completed. Now, what happened? S1 is to H1 is to HB is to HN. 1 is to 4 is to 9 is to so on n square. Next, S1 is to S2 is to so on Sn. 1 is to 3 is to 5 is to so on 2n minus 1. Next, AB distance value will be 1 by 2 G T2 square minus T1 square. Time to come from A to B, this value will be root 2 by G into root H2 minus root H1. Next, splash of sound well problems, then T is equal to root 2h by g plus h by v sound. Next, after this, for T3 is equal to root of T1 square minus T2 square. So 10 seconds it is taking to reach the ground, but after 6 seconds it is stopped. Still how much time it is taking means 10 square minus 6 square, 100 minus 36 means root 64, that will be equal to 8 seconds. It won't take 4 seconds, it will take 3 seconds to reach the ground. These type of problems will be there on the freely falling body. Next, vertically projected body we will discuss. Vertically projected body. From the ground, if a body is projected vertically up into the air, that body will be called as the vertically projected body. So, this is ground. From the ground, one body is projected vertically up. From the ground, one body is projected vertically up. Then that body will be called as the vertically projected body. Clear? Then for a vertically projected body, what formulas you have to use? See, it should not be like this. It should be this body should make an angle 90 degrees with horizontal. Means straight vertically we are projecting up. What will happen? We have to project it with some velocity. When it is going up, its velocity will gradually decreases. When it is going up, its velocity gradually decreases and finally somewhere it becomes 0. Then again from there it will fall down. Clear understanding? So when the body is going up like this, velocity decreasing, and when it came to here, let the velocity becomes 0. From where velocity becomes 0, from there again it will fall down in the same path and reaches to the point of projection. From where it is projected, it will came to the same point. Clear? So, what are the equations of motion of a vertically projected body? In the same way, for a vertically projected body, what are the formulas for maximum height, time of ascent, time of descent, time of flight, everything one by one we will discuss now. So, vertically projected body means a body projected into air vertically. A body projected into air vertically is called vertically projected body. Okay? That vertically projected body, how much angle it is making with the ground? It is making 90 degrees with the ground. Next. Then, what are the parameters, equations of motion? Equations of motion for a vertically projected body. For vertically projected body, what are the equations of motion? Okay. Here what to consider is, For vertically projected body, A value will be minus G. For vertically projected body, A value will be minus G. If we substitute only this one in the formulas, what are the equations of motion? V is equal to U plus AT. S is equal to UT plus half AT square. V square minus U square is equal to 2AS. Sn is equal to U plus A into N minus half. These are the equations of motion. If we substitute A is equal to minus G, here what we will get is V is equal to U minus GT. This equation. H is equal to, generally we will write H instead of S. H is equal to UT minus half GT square. Just you substitute A is equal to minus G here. Next here, V square minus U square is equal to minus 2GH. Here Sn is equal to U minus G into N minus half. So, these are the equations of motion of a vertically projected body. Equations of motion of a vertically projected body are this one. Clear? Next, after finishing of this, let us discuss about the parameters of the vertically projected body. Next, after finishing of this, parameters of a vertically projected body. First one will be maximum height. This will be represented by the letter capital H. Maximum height is represented by the letter capital H. How it will be defined? So, the distance traveled by a body. The distance traveled by a body of a vertically projected body. The distance traveled by a vertically projected body before its velocity becomes zero. Before its velocity becomes zero. How much distance traveled by the vertically projected body is called maximum height. So, this is the ground. From the ground, we projected a body up. When the body is going up, what will happen? Its velocity gradually decreases. Finally, here its velocity will become zero. With velocity u, we projected. Its velocity when it is going up, we know its velocity gradually decreasing. and finally somewhere it becomes 0. This distance will be called as the maximum height. From here to here, that will be called as the maximum height. So for this, what is the expression for maximum height? So for this, consider a body projected vertically into a with velocity. Consider a body projected vertically into air with velocity. Okay. Let one by one we will discuss relating to this. H be the distance traveled by the body. Let H be the distance traveled by the body before it coming to rest. So what we are considering, this distance, let it be H. Clear? And then one by one try to derive the formulas, see how to derive. What is the initial velocity here? With what velocity we are projecting? U. So initial velocity is equal to U. What is its acceleration? Body acceleration symbol is A. That A value here it will be equal to minus G. A is equal to minus G. What is its velocity? Final velocity. V is equal to 0. U value is equal to U. Final velocity symbol will be V here. The V, that V value here how much means that will be equal to 0. Next, displacement S is equal to how much means H. If we substitute all these values in that, we will get from V square minus U square is equal to 2AS 0 minus U square 2 into minus G into H. We substituted these values in this formula. Then 0 minus U square is equal to 2 into minus G into H minus U square is equal to minus 2GH. So minus minus becomes plus. Then H is equal to U square by 2G. This is the formula for maximum height. Okay. The vertical distance traveled, by a vertically projected body before its velocity becomes 0 is called maximum height. So initial velocity will be U. Because it is going up, A is equal to minus G. Why it is minus G? Its velocity is decreasing. Body is attracting towards the earth. That's why we have to take A is equal to minus G. Final velocity will be 0. Displacement will be H. By substituting all of these, we will get H value is equal to U square by 2G. Next, what is meant by time of ascent? What is meant by time of ascent? Second one. Time of ascent is indicated by the letter TA. It is indicated by the letter TA. How it will be defined? From here, this is called point of projection. From where you are projecting, that will be called point of projection. It is reaching to here. Where it is reaching, that will be called highest point. Where final velocity becomes 0, that will be called highest point. Time taken by the vertically projected body to reach the highest point from point of projection. From here to reach to here, how much time it is taking? That time will be called as the time of ascent. How we will define? The time taken by the vertically projected body. The time taken by the vertically projected body to reach the maximum height, to reach the maximum height from point of projection. To reach the maximum height from point of projection is called time of ascent. That will be called as the time of ascent. Clear the point? So here what will happen? It is indicated by the letter T. So what is initial velocity? Initial velocity u is equal to u. What is acceleration? A is equal to minus g, acceleration. Next, what is final velocity? Final velocity v is equal to 0. What is the time? Time t. We are taking it as ta. By substituting all of this in the formula, from v is equal to u plus at. v is equal to u plus at will be the equation of motion. If we substitute all this, what we will get? See, this is 0, this is u, a value minus g, t value will be ta. So gta is equal to u, ta is equal to u by g. So expression for time of ascent, ta value will be equal to u by g. This we calculated. Next, of this, what is time of descent? Understanding? The time taken by the vertically projected body to reach the maximum height from point of projection is called time of ascent. So here this we will get in the upward journey. U value, upward journey means here to here. A value will be minus g, final velocity will be 0. Time t is equal to ta. By substituting all of this, what we will get? Time of ascent is equal to u by g. Next, time of descent. Time of descent is 3. This will be represented by the letter TD. From here to come to here. From here to come to here. How much time it is taking? That will be called time of descent. time taken by the body to reach the point of projection from highest point. The time taken by the vertically projected body to reach the point of projection from highest point is called time of descent. This will be indicated by the letter D. The downward journey we will consider here to here. What we will get in downward journey. Here to here. This is the starting point we have to consider. There, what is the velocity? Initial velocity u is equal to 0. There is no velocity here. From there it has to come to here. It is just like freely falling body. So, acceleration is equal to g, because it is moving towards the earth. Time, this value, time is indicated by the letter t. Here that is t. What is the distance? S is equal to, here to here, the value will be h. That value will be equal to u square by h. Okay? By substituting all these values in v square minus u square is equal to, or will do what? We will use s is equal to ut plus half et square. If we use this one, s value will be h. That value will be u square by 2. U value 0, this term will become 0. 1 by 2 g td square. 2 will cancel. This g will comes to here. U square by g square is equal to td square. From this td is equal to u by g. So time of descent, that value will be equal to u by g. Time of ascent already how much we got? U by g. Time of descent also how much we got? U by g. So we can say time of ascent is equal to time of descent. We'll continue in the next class. Okay.